Hey guys, this is Steve from the BTI Web Services team. Today we'll be talking about RESTful ext data stores. This is part one of a two-part series. We'll only be looking at the JSON implementation of the ext data store writer. So the overview is that we're going to be looking at the ext JSON writer. We'll also see how the store converts CRUD operations into RESTful URIs. We'll also show how to override those default store URLs that are generated. We'll see how the store autosave works, and we'll also look at how record transactions work within the store. So the ext JSON writer is used to fulfill both all of the save, update, and delete store operations. We'll be looking a little bit later on to see how to actually implement those operations. Right here you're going to see the JSON writer config operations. Right now I have these two fields set, write all fields and encode false. So what happens with write all fields is that if you set it to true, all the data available in that record will actually be sent back to the server. If it's set to false, the store actually recognizes what fields have changed in that record and will only send that changed data to the back end. We also set it to false to send the data as JSON data inside the request instead of passing it as an HTTP parameter. So here are the store operations to produce the web services call. So if you want to create an object in the store, you just call store.insert. You put it at the index of where you want the record to be put in the store, and you pass the record. Then to load the store, you just call store.load. To save, this will actually set the property, for the property that you want in the store, you set the value. And then to destroy the record, you just call store.remove and you pass in the record that you want removed. In order to define a store as RESTful, you need to have a config option called RESTful, and you want to set that to true. If you pass in a URL, in our case dictionary.json, it'll generate different URLs based on the CRUD operation that we're performing on the store. So the default operations are create, which defines a HTML operation of post. The URL that's passed to the backend is dictionary.json. Likewise, you got load, which generates an HTML operation of get with a URL of dictionary.json. Now you've got the save operation. Well, that's going to generate a put. And now, instead of the standard dictionary.json, we're actually going to be passing the ID of the object that we're passing after dictionary. So it's dictionary/id.json. Likewise for destroy, which will generate an HTML operation of delete and passing that ID to the backend. If we want to override the default store URLs, we can use something called an HTTP proxy. We can still define our default URL of dictionary.json, but let's say that we wanted to change the save operation to actually call dictionary/update.json. And instead of using a put, we wanted to use a post method. If we wanted to change the URL of create, we'd just do dictionary/new.json. And since we didn't change the method, it'll still generate a post. Here's a table of the operations. Once again, we'll see that the create has a post with a new dictionary new.json. Load, same default get operation on the dictionary.json. The save will generate the post because we overrode the default implementation, but it will also pass back the ID because it needs to specify which record it's saving. The destroy will continue to use the default implementation. So the store autosave. If autosave is set to true, once the record is modified in the store, it actually gets sent to the backend. Now there is a difference in here, which we'll be talking about in part 2, where you can actually specify in the record what you want, if you want a record to be empty or not. So if a record field says, hey, don't be empty, well, if that field is empty, it's not going to be sent to the backend. We'll go a little bit more into detail about that with part 2. But if we say autosave is false, the call won't be made by itself. We need to call that method. So if you want to call save on the store, you just call the store save method. Everything, all outstanding changes in the store will actually be saved at that point in time. Likewise, if you want to roll back changes, you're going to want to call reject changes on the store. That'll take all of the modified records and will roll them back to their original values. Another thing to look at is record transactions. So record transactions are useful when a store's autosave is set to true. So what we like about this is you can set multiple record properties in a record without sending this update operation on the store multiple times. I'll be showing an example of that right now. So here's the record transactions example. As you can see, we're going to start calling begin edit on record. We're going to set two property values, property 1 and property 2, set them to both value 1 and value 2. We could say if the user really wants this edit, we can call record.endEdit. Once you call endEdit, the store will see that that record has been updated and it will be sent to the backend at that point in time. And if the user really didn't want those edits, they can just call record.cancelEdit. That'll roll back the changes in the record and nothing will be changed. So let's look at our implementation of a EXT RESTful Data Store with a JSON Writer attached to it. So right now we define our RESTful set to true. So that's going to generate our pretty URIs matching the RESTful Web Service standard. Then we define our URL that we want. We also set autoload set to true, so whenever this store is created, it's actually going to go fire that load event for us automatically. Then we define our JSON reader. So we define our success property. So this is important for stores because in order for them to recognize that a message was successful, it doesn't look at the header, or it doesn't look at the response code. So the 200 is okay, but 400 is bad. If it doesn't see the success true in the response, it won't think that it was actually successful. So this is important that you need to send this back in the web service call that you bring back. We'll go into detail in part 2 as to what the store expects to see back in the response. The next thing is the ID property. This is also very important because in order to initiate a delete or update command, it needs to pass that ID to the back end so that the back end service actually knows what it's deleting or updating. Then we've got the root. So this says all the data is going to be within this data tag in the JSON property. So then the store actually contains 3 fields: an ID, name, and definition field. We'll go into detail about allow blank and other record options in part 2 as well. Another thing is this JSON Writer. So we need to plug in this JSON Writer into the store in order for all these cool little functions to work. So we've got this encode false. Once again, it's going to be put in the JSON data tags in the request body. Then we're going to send all the fields to the back end because our service, we are just binding to that object in Spring and we're just going to go save that data. Then we also set autosave set to true. We can change this if we want to. I'll be showing both ways, autosave set to true and false. So actually let's look at this little application. So let me refresh this. So right when we log in, you see that we get a get operation. That loads this grid panel, or this grid panel right here. So we've got 2 records, and let's say that we want to update this. Say, oh, well, I want to capitalize that L in list. Let's hit update. All right, as you can see, it generates a put. So put BTI dictionary ID of 1.json. We passed that, and it was successful in that update. Now let's say, all right, I don't want this word. Let's delete that word. Once again, you see the delete command with passing the ID of 0. Let's say that we want to have a new word. So let's say set a collection that guarantee that has unique records. Update. So this actually generates a post, and it has the dictionary.json. It defined a new ID for us, which we'll go into part 2 as to how this all happens on the back end. So now that we looked at how autosave works, let's actually take autosave off. So this removes autosave, and we can actually modify this word to say, set to. We'll update that, and you can see that this word has been modified. This grid puts that little red arrow up there to say that the record is dirty. So if we call save on that, it'll update it to set to, and it removes that little red arrow in the upper left corner to say that it is no longer dirty. So let's talk about, well, let's reject those changes. So we've got this command here. We get the store and we call reject changes. Okay. So if we modify this back to the original set, we hit update, still sitting there. And if we run this, it'll reject the changes, and then when we call save, it'll actually not send out a command because those changes were rolled back before we call save. So let's give it a shot. Once again, it was rolled back to set 2 instead of what we put in there as set 1, or rather set. We rejected those changes, that rolled back, and the save didn't do anything. So let's go a little bit further, and I'll show you when you have all these different things piling up. You can see, let's say, new word, a word. Okay, update. Okay, so that's queuing this thing. Then we say another new word, yet another new word. Let's update that. Let's set this back to 1, or sorry, without the number. And then let's actually delete the list. So what's going to happen is you're going to be seeing a lot of activity in the console, in the Firebug console. You're going to see 2 new posts. You're going to see a delete, and then you're going to see a put because we did all those operations. So let's go ahead and hit run. There you go. You got a delete, 2 posts, and a put to clear out that store and commit all modified records. Alright, let's take a look at changing the default implementation of the URIs. So we've got our HTTP proxy, which defines the dictionary.json. Once again, we've got the create, which we want to say dictionary/create.json. And for the update, we want to keep the default, except we just want to change the method to post. So all we do is get rid of the URL, and we uncomment this and define our proxy in the EXT Data Store. So let's refresh this. Let's change this to new word 3. We got autosave set to true again. Before that generated a put, but now it generates a post. Let's go ahead and add a new one. New word 4. Let's say new definition, new def. Let's update that, and you can see that we hit the dictionary/create.json. So hopefully that was helpful, guys. Catch part 2. We'll go a little bit more into detail as to the backend services, but hopefully this was a quick overview for the ExtJS Store. Thanks. Bye.